So hi everyone, welcome back to another video, and today we're going to be solving Cambridge IGCSE Chemistry Paper 4 Theory Extended May-June 2024 Paper 42. If you guys are doing O-Levels, this video is really going to be helpful for you guys as well, because after the recent syllabus updates, the Cambridge IGCSE syllabus and the Cambridge O-Level syllabus is exactly the same. So these papers are going to help you practice. So let's get started with the first question. A list of gases is shown. Okay, we have a list of gases. Answer the following questions about these gases. Each gas may be used once, more than once, or not at all. Always before looking at the question, always try to know the gases by yourself. Okay, ammonia gas, we know that it is produced by the Haber process. Write down all the information. I'm going to write in all the information I know about these gases before even looking at the question. So I know ammonia is used in the Haber process, and then it is made up of nitrogen plus hydrogen forms 2NH3. And then we have a helium gas. I know that helium gas is a monatomic gas. Monatomic means that it is made up of a single atom. Okay? It does not exist as molecules. It's a single atom. Okay? Then because it's in group 8. Group 8 means full outer electrons in the shell. Hydrogen gas, a very famous gas again, used in the Haber process, used in the hydrogen-oxygen fuel cell. Then carbon dioxide gas, again, causes global warming and has a lot of other uses, is a covalent structure. Then I have carbon monoxide gas, that's a toxic gas. Okay? CO is the formula. Then we have chlorine gas, Cl2 gas, that's a very famous halogen, a strong oxidizing agent, a greenish yellow gas. Then we have methane. Methane is CH4, and this gas is basically very famous because it causes global warming and increase in Earth's temperature. Moreover, for methane gas, we know that it is used to extract out hydrogen, okay, for the process. If you guys remember the Haber process, for Haber process you get the hydrogen from methane. Okay, it is clearly stated in the syllabus. I wish I could show to you guys as well. If I could, then this is your syllabus, and this is a recently added thing in the syllabus, so you guys should learn it. If I can find the Haber process over here, that you get your wait a second. That's a recently added thing, and that's very important. I guess all of you should know and learn it, because you guys think that we get hydrogen from the electrolysis or from hydrocarbons, but it is added to the syllabus that you get your hydrogen by methane. Okay, read this point, this 6th point. State the sources of hydrogen, okay, which is methane, and nitrogen, air, in the Haber process. That was what I was saying. This is a very important point. Most of you might think that we get hydrogen from the electrolysis of water, or some of you might think we get hydrogen from your cracking of hydrocarbons. But in the syllabus, it's clearly stated that you get your hydrogen for the Haber process from methane. Okay? I hope you guys are good to go. Okay? Now we have nitrogen dioxide. Okay? Again, NO2 causes acid rain. Then we have propene. Propene is an alkene. It's gonna turn aqueous bromine from orange to colorless. Why? Because it's an alkene, and that's a property of alkenes, that they turn bromine water from orange to colorless. Then we have sulfur dioxide, SO2 gas, and for that as well, this is a strong reducing agent. Okay? It's a very strong reducing agent. It is gonna turn your... How come I know all these things? All of this is written in the book. All of this is written in the syllabus. Please go consult the syllabus, learn all the points, important things from the syllabus and your books. Okay? It's a strong reducing agent. It is going to turn your potassium permanganate paper or solution from purple to colorless. Okay? Now we're good to go. State one gas which is the main constituent of natural gas. That is CH4. Your methane is your natural gas composes mainly of methane. Okay? That's why it's highly flammable. Why? Because methane is a hydrocarbon. It's an alkane which combusts in the presence of oxygen to produce carbon dioxide and water. Is responsible for both photochemical smog and acid rain. Okay, now we have two gases which can cause acid rain. First we have sulfur dioxide, then we have nitrogen dioxide. Both of these gases is going to cause acid rain. But the problem is that we cannot write both. So we have one more hint that we're given in the question, that is photochemical smog. And photochemical smog is caused by nitrogen dioxide. When this nitrogen dioxide reacts with other hydrocarbons in the presence of UV light or sunlight, it causes photochemical smog. And photochemical smog is basically brownish kind of a gas in color. It's brown, and you might have seen some cities infected with it. They are covered, the valleys. Basically, smog affects more of the valley areas and more areas that are congested. Why? Because it settles down and it's mainly in winters, and it's caused by this NO2 as well as the hydrocarbons. Is unsaturated. Unsaturated mean it's an alkene, and that's going to be propene. We only had one alkene in the entire list, and that was propene. Let's move on. Is monoatomic particles, obviously that's going to be helium particles. We just had one monatomic gas in the entire list, that was helium. Reduces iron 3 oxide in the blast furnace. Okay, you should know the equation for the blast furnace by heart. That's a very important equation. That was that you take iron oxide, iron 3 oxide plus 3 carbon monoxide, and this is your reducing agent, and it converts it into 2Fe plus 3CO2, and basically your Fe2O3 is reduced. Why it is reduced? Because it lost oxygen. Over here, look over here, this side of the equation, look at this side. This side of the equation, it over here iron has O3, but over here iron lost its O3. So that is, what is that? That is reduction, because iron oxide has lost its oxygen. So this is going to be the reducing agent because it reduced iron 3 oxide. So the reducing agent in this is carbon monoxide. So you're going to write carbon monoxide. Okay, let's move on. Nitrogen dioxide and carbon monoxide are removed from car exhaust by catalytic converter. Write the simple equation for this reaction. Nitrogen dioxide plus carbon monoxide removed from the car exhaust by catalytic converter, and we have to write the simple equation. We have taken nitrogen dioxide, we have taken carbon monoxide, now we convert it to nitrogen and carbon dioxide. Why? Look, nitrogen dioxide is more harmful. It causes acid rain, it causes respiratory problems, it causes photochemical smog, it has a lot of problems, okay? Whereas nitrogen gas is the main constituent of your air. Your air 70% is made up of nitrogen gas. So when you convert your nitrogen dioxide to nitrogen gas, you're basically converting it into a less harmful substance, okay? So basically what you do is you're making it less harmful. And similarly, carbon monoxide is a toxic gas, whereas carbon dioxide also causes global warming, but it is not as toxic as carbon monoxide. So you convert it into carbon dioxide, and then you have to balance the equation as well. I'm just gonna try to balance it out. I'm trying. Balancing is hit and trial method. You just write some numbers, you look at them. On this side we have 3 carbons, and over there oxygens, and over here we have and we're done with the balancing. Okay, balancing is always tricky and it may take you some time, as it also took me some time, but after some time you're gonna figure it out. Okay, let's move on. ठीक है, a list of 5 metals is shown. ठीक है, copper, iron, magnesium, potassium, silver, all metals form positive ions. Describe how atoms form positive ions. You have atoms and you're forming positive ions. Positive ion means you have more protons, but obviously you cannot change the proton numbers. Positive ion means that this is your shell, this is your electron in your shell, and you basically lose the electron, and then you get your positive ion. So you're going to write by losing electrons. That is how you form your positive ions. Okay, let's move on. State which of the 5 metals in the list has the greatest tendency to form positive ions. The more reactive you are, the most reactive metal has the greatest tendency to form positive ions. ठीक है, the more reactive you are, the more readily you are going to lose this one electron. ठीक है, for example, if I take sodium and lithium, ठीक है, this is my sodium atom, this is my lithium atom. I know sodium is more reactive, so what will happen? Sodium will lose this electron more readily. It will take more time for lithium to lose the electron. ठीक है, sodium will lose it in 5 seconds, so lithium will lose it in 10 seconds. It will take more time for lithium to lose it because lithium is less reactive. So more reactive you are, the more tendency you have to lose this electron. So it's going to be the most reactive out of them. I guess we all know it's going to be potassium because potassium is the most reactive according to the reactivity series. Okay, go learn the reactivity series if you are unable to figure it out. Okay, suggest one of the 5 metals in the list which is not likely to show catalytic properties. Not likely to show catalytic properties. First of all, what do you guys think? Which, elements are catalysts? You should know that you use your transition elements as catalysts. Okay? Your transition elements make up catalysts. So we're going to figure out that which of these elements is not a transition element. Obviously, that's going to be the one that's not going to show catalytic properties. Okay? Copper is a transition element, cut it down. Iron is also. Magnesium is not. Potassium is also not. And silver is also a transition element. So it's either going to be magnesium or potassium. So you can write magnesium or potassium. Any one of them. Okay? Let's move on. State which of the 5 metals in the list is a major component of stainless steel. Stainless steel. Does this makes you get onto something? It's going to be iron. Steel is made up of iron. Okay? And we have iron in the list as well. So obviously it's going to be iron. Okay, let's move on. A student adds a sample of a metal to an aqueous metal salt in a beaker to see if displacement reaction takes place. Complete table 2.1 to show the color of the solution in the beaker at the start and at the end of the experiment. Okay, you have your metal, you have your aqueous solution. Okay, in magnesium metal, and you have iron sulfate. Iron salts, they're green. For copper sulfate, color at the start is obviously going to be blue. Okay, that's what we know. Okay, color at the end, magnesium is more reactive than iron. Okay, if I draw the reactivity series, magnesium is above iron. So when we have iron sulfate, what basically happen will magnesium will take the place of iron, so it will become magnesium sulfate and iron will be precipitated out. Okay, so now this becomes salt solution becomes magnesium sulfate, and magnesium sulfate is a colorless solution, so from green to colorless. Okay, next we have silver. Again, copper is above silver in the reactivity series, so if we have a salt which is copper sulfate, silver won't be able to displace copper. Why? Because silver is below copper in the reactivity series. Okay, so blue solution will remain blue. Okay, let's move on. Most group 2 metals form a gas when placed in cold water, and the name of the gas is hydrogen gas. You should know metal plus water forms hydrogen gas. An alkaline solution is also formed. Name the gas form when strontium is added to cold water. Hydrogen gas. Name the alkaline solution form when strontium is added to cold water. That is strontium hydroxide. How do I know it? I'll tell you guys. Strontium hydroxide. Because whenever you're going to take strontium, for example, if you take lithium, let's take lithium. Lithium plus water is going to form lithium hydroxide, LiOH plus H2 gas. Okay? So you form an alkaline solution of hydroxide and hydrogen gas. So same goes with strontium. It's going to form strontium hydroxide and hydrogen gas because strontium is in group 2. So for group 1, this is group 1. Lithium is group 1, and group 2 metals, you form an alkali and hydrogen gas. One group 2 metal reacts very slowly when placed in cold water. When heated, the metal will react with steam to form a white solid. Identify this metal and the name of the white solid form. Very slowly with cold water. Okay? Calcium reacts rapidly with cold water. Remember that the metal that reacts very slowly with cold water is going to be magnesium. And the metal reacts with steam to form a white solid. Steam, H2O. The white solid will be magnesium hydroxide. That's magnesium oxide. With steam they form oxide, then with cold water they form hydroxide. So the metal is for sure magnesium, and the white solid is going to be magnesium oxide. Under certain conditions, iron will react with steam to form an oxide iron with the formula Fe3O4. Fe3O4 reacts with dilute hydrochloric acid to form a mixture of iron 2 and iron 3 salts and water. Reduce the symbol equation for the reaction between Fe3O4 and dilute hydrochloric acid. So we have Fe3O4 plus hydrochloric acid, and what do we form? A mixture of iron 2 and iron 3 salts. Okay? We have an oxide plus an acid, and we form the salts are iron 2 and iron 3. So it's going to be iron 2 chloride. It's going to be FeCl2. This is iron 2 chloride. Why? Because iron 2 means an iron has a charge of 2 plus, and this 2 plus goes down over here with the chloride. So iron 3 will mean iron has a charge of 3 plus. So chloride is -1. So it will be FeCl3. This 3 goes down here, this 1 comes here, and 1 we don't write, so it's going to be FeCl3. So it's going to be plus FeCl3. Okay, these are the two iron salts, FeCl2, FeCl3. And water. Okay, they told us all the products. Reduce the symbol equation for the reaction. Okay, we have written the symbol equation. What's left is balancing. Okay, balancing is just hit and trial. Look at it, try to figure it out. I'm also just try it on your notebooks. Write the equation and try it. It's gonna, occur slowly. Done. 8, 2 and 4. It's 8, 2 and 4. I just tried it and you just have to wait and balancing will come out slowly, okay? I guess that is balanced. Let's move on. The simple equation for the industrial production of ammonia is shown. Name the industrial process. Well, to produce ammonia, that's a simple process known as the Haber process. State the meaning of delta H. You don't even need to think about it. It's enthalpy change. State the typical conditions and name the catalyst used in the industrial production of ammonia. You just learn these conditions by heart. 450 degrees Celsius, 200 atm pressure, and catalyst is iron catalyst. State 2 methods of increasing the rate of this reaction. You got to increase the rate. To increase the rate, what you're going to do is you increase your pressure. Increase pressure means that the particles closer together will react fastly, and you increase the temperature. Increasing temperature means that the particles have more energy, will collide more frequently. Okay. The simple equation for the reaction can be represented as shown in figure 3.1. Okay. We are given with our enthalpy change. These are bonds broken, and these are your new bonds that are being formed. Okay. Table 3.1 shows some bond energies. Use the bond energies in table 3.1 and delta H to calculate the bond energy for an NH bond in kilojoule per mole. Use the following steps. Calculate the energy needed to break bonds in the reactants. Okay, energy needed to break bonds in the reactants. HH bond, how many HH bonds we have? We have 3 HH bonds, and the energy for one HH bond is 435. So it's going to be 435 times 3. We have one nitrogen triple bond, and the energy is 945. So these are the total energies on this side of the equation. Okay? This is your equals to sign. So just add them. Okay, so let's multiply this. Calculate the energy needed to break the bonds in the reactants. Okay, we have to calculate the energy in the reactants. You know, these both are your reactants. On this side of your equation are your reactants, and on the other side of your equation are your products. Okay, so as we know, for reactants is going to be 945 plus 3 times we have this nitrogen hydrogen these hydrogen bonds 1, 2 and 3 times. Okay, so it's going to be 3 times 435. Put it on your calculator as it is. 945 plus 3 times 435, and that's going to give you 2250 kilojoules. Okay, now this is the amount of energy we needed to break all these bonds. Okay, 3 of these bonds and 3 of these bonds. Okay, so the total energy we needed was 225 and 0. Okay, calculate the energy released when the bonds form in the products. Okay, we have to calculate the energy released when the bonds form in the products. Okay, to calculate the energy released, we have to look. Now I tell you what basically is happening. When we are breaking these bonds, we are absorbing energy. Okay, when we are breaking these bonds, what we're basically doing is we're absorbing energy. Energy is going into the bonds. Write this like into. When we are forming these bonds, what's happening is, देखें यहाँ पे hydrogen का bond is being broken. ठीक है, so energy is going inside. When this nitrogen bond is forming, energy is coming out of the bonds. When this nitrogen bond is forming, what's happening? Energy is coming out of the bonds. ठीक है, so you got to make sure that over here energy is released and over here energy is absorbed. So the amount of energy released would be, we have to calculate the total amount, okay? Now basically energy absorbed we just calculated, needed to break bonds is the energy absorbed, which was 2250. When we subtract, look over here, this is the energy absorbed, okay? This is the energy absorbed, and we subtract from it the energy released. We don't know the energy released because we're not given it, so we write X for energy released, okay? I am just gonna write over here that this one is your energy absorbed, okay? And X is your energy released, okay, which you don't know. And when you subtract, okay, over here this is the formula, you just subtract all your energy absorbed and the released one. The answer you get is your enthalpy change. Your enthalpy change is negative 90 kilojoule per mole. So the answer that you're gonna get after doing this is gonna be is equal to negative 90. Okay? From here, can you figure out the value of your energy that is released? You just move your X over here, your 90 over here. It's going to be 2250 plus 90 is equals to X. And you just add 90 to it, and that's going to give you 2340. 2340. Okay, so now what basically happened is, you know the amount of energy released, and now you have to calculate the energy for an NH bond means that a single NH bond, one NH bond, okay? Now you know that energy released for all the NH bond, I'm sorry for this, let's move on. Okay, so the energy released for all the bonds, okay, in together were how many bonds we had of NH were formed. Let's take a look. 1 2 3 4 5 6. We were forming 6 bonds, okay? So we know that the energy released for forming 6 bonds was this one, okay? We calculated it, 2340. Okay, for 6 NH bonds, which I just told you that we form 6 bonds right over here, 3 in this one, 3 in this one. So the energy released for 6 bonds was 2340. For 1 would be X. We form a ratio, 2340 divided by 6 is going to give you the value of X. And put it on your calculator and you're going to get 390 is equals to X. And X is your energy for breaking one bond. That's going to be 390 kilojoule. Now you don't put negative 390 because you already know that that is the energy for NH bond. Okay, it's not for breaking or forming. It's just the energy for breaking or forming or whatever for one NH bond. For example, if you had a table and over here you had your NH bond as well, NH, so it's going to be 390. Can you see any negative sign with any one of them? So you don't put a negative sign over here. It's just 390 kilojoules per mole for breaking one NH bond. Okay, so we're done with it. Let's move on. An incomplete simple equation for the preparation of ammonia in the laboratory is shown. Okay, complete this simple equation. Okay, so you have an oxide. Take care. And this right here is an ammonium salt. Okay, you just label out everything you have. This is an ammonium salt, and what I'm forming is I'm forming salt plus this is my ammonia gas, and they're asking me what will I form over here. Do you guys remember the reaction between ammonium salts and bases? Bases react with ammonium salts to produce salt, water and ammonia gas. Okay, similarly, just learn this reaction. I'm going to write it for you guys over here. Learn it, it's very important. Base plus ammonium salt. Okay, similarly, acids react with carbonates to form carbon dioxide, water and salt. Bases react with ammonium salts to form ammonia plus water plus salt. The salt is not going to be ammonium salt, it's going to be some other kind of salt, okay? ammonia, water, and salt. I'm highlighting this so you guys should learn it. This is very important. To get done with it, so this is going to be water. And now you just balance it. 42 times 8. Just write an 8 over here. Oh, we have hydrogens over here as well. Sorry for this. Just look at all the hydrogens and balance them. 3 2 times 6 7 8. It's balanced, already balanced. Okay, let's move on. Name this. This is ammonium ion. This is chloride ion. Okay, chlorine, but over here there's a +1 over here, a -1 over here. We cannot see because it's neutral, it's balanced. All these both moved over here, so this is going to be ammonium chloride. Why? This is an ammonium ion, +1. This is a chloride ion, -1. So we're going to write ammonium chloride. Okay, calculate the volume of ammonia NH3 measured at RTP, which forms 1.12 grams of CaO. When 1.12 grams of CaO, calcium oxide is heated with excess NH4Cl. Okay, you have to calculate the volume of ammonia. Dekhen, first what we're given with mass of this thing, okay? From the mass, we can easily calculate the moles of this thing, this calcium oxide, okay? Let's calculate. First, we should know the MR. We are given the MR, it's 56, okay? So for moles, we're going to be moles is equals to mass. Mass is 1.12 over MR, which is 56. Put it on your calculators. 1.12 over 56 is going to give you 0.02 moles. Okay, now we know the moles of calcium oxide. Okay, now look at the equation carefully. This is a balanced equation. Okay, in a balanced equation, we can see that 1 mole of calcium oxide is going to form 2 moles of ammonia gas. I'm going to repeat it. What I said was 1 mole of calcium oxide will form 2 moles of ammonia gas. How I know? Because the ratio is given in the equation provided in the question. So I know that CaO, wait a sec, I know that my CaO ratio ammonia NH3 is 1:2. Okay, that is what I know. That calcium oxide ratio ammonia is 1:2. That was given. Now, how many moles of calcium oxide do I have? The question is given me. I know it. I know that the question gave me the mass and the MR, and I calculated the moles, which were 0.02. So these are going to be X. And what does the value of X come out to be? When you multiply this with this, so multiply 0.02 with 2, and you're going to get 0.04 moles of ammonia of NH3. Now you have the moles of ammonia. Do you guys remember formula for volume which we used to use? The formula for volume, that moles is equals to volume over 24. If we are asked for the volume in dm cube, so we take 24 dm cube. If we are asked for the volume in cm cube, then we take 24 cm cube. Over here in the answer space, where's the answer space? We are asked for volume in cm cube. So now we don't take 24 dm cube because we're not asked in dm cube. We take 24,000 cm cube. Okay? Let me repeat my statement. Look, in the answer space, it was given that I had to give my volume in cm cube. So I took 24,000 cm cube as my denominator. If I was asked to calculate my volume in dm cube, then I would only take 24 dm cube over here. Okay? But right now I'm asked in cm cube, so I'll take cm cube in my denominator. Okay? I know my moles. I just calculated them out. It was 0.04. I know this is going to come over here, get multiplied with the moles. 24,000 is going to be my volume. So multiplied by 24 1000, and that's going to give me 960 cm3. Okay, done with it. Let's move on. A carboxylic acid reacts with an alcohol to produce an ester and water. Under conditions, the reaction can be reversed. So an ester reacts with water to produce carboxylic acid and alcohol Y. The reaction reaches an equilibrium. Okay, the forward reaction is endothermic. Deduce the empirical formula of the ester. Okay. Now this is basically what I'll explain it to you. Now this X is your carboxylic acid, okay, written in the question, carboxylic acid X, and Y is your alcohol, written in the question, alcohol Y. Now what is happening is that you remember that when an acid, carboxylic acid, was reacting with an alcohol, what would you form? You will form, if we go on this side, you'll form an ester. This one is an ester, plus you form water. And now they're saying that this reaction is reversible, so the ester and water can combine back to form your acid and alcohol. So that is why there's an add of reversible reaction, okay? So that's what's basically happening over here, and they've given us one more piece of information where they tell us that the forward reaction is endothermic. This one is the forward reaction, endo, okay? And obviously when I know my forward reaction is endo, I get to know one more thing, that my backward reaction is going to be exo. Okay, always know when your forward is endo, backward is exo. When forward is exo, backward is endo. Okay, reduce the empirical formula of the ester. Okay, we calculate the number of carbons, then oxygen, and then hydrogen. 1 carbon, 2 carbon, 3 carbon, and 4 carbon. So first I write on the side C4. Now I calculate the number of hydrogens. 3 hydrogen, 4, 5, and 6, 7, 8. Okay, H8. Now I calculate the number of oxygen. 1 and 2 oxygen, so it's going to be O2. Now I find on which table does all three cut. So I can find table of 2. 2 1 times 2, 2 4 times 8, and 2 2 times 4. Do you get me? I cut all of them on the table of 4. On the table of 2, okay? 2 2 times 4, 2 4 times 8, 2 1 times 2. So that's going to make it C2H4O. Okay, I'm done. Name the ester. So to name the ester, what we have to do is we have to cut the ester to look at the alcohol part and at the acid part. Always remember, you cut the ester from the ester linkage, which is when you have 2O. Okay, and always remember this thing. Always remember this thing. This is a very important thing. This left part, this is going to be probably the left part, is always going to be this part of the ester is going to be your acid, and this part is going to be your alcohol. Okay, now for acid we have 1, 2, and 3 carbons, so that's going to be propanoic acid. Okay, for acid we have 3 carbons, that is propanoic acid. For alcohol we just have 1 carbon, so that's going to be methanol. Okay, now we have the name of the acid and we have the name of the alcohol. Now when we form ester, remember to name an ester, first we write the name of the alcohol and then we write the name of the acid. So the name of the alcohol was methanol, so it's going to be methyl, and then the acid was propanoic acid, so propanoate. Okay, so it's going to be methyl propanoate. Okay, name carboxylic acid X and draw its distillate formula. We just figured it out that our carboxylic acid X was which acid? It was propanoic acid. We cut down an ester and we looked at it carefully. So it's going to be, I know it's going to be propanoic acid. And in order to draw my propanoic acid, what I'm going to do is, first I'm going to draw 3 carbons, then I know it's an acid, so it's going to have an acid functional group that's carbon double bonded ONH. Now I'm done with all the things I have to. Now I just have to fill it with hydrogens. Done with my propanoic acid. Name the alcohol Y and give its structural formula. Now they've not asked for the distillate formula, they've asked for the structural formula. Okay, I know that it was methanol, so methanol, And structural formula. I'm going to explain you what is a structural formula. Okay? First, you draw the distillate formula of methanol, and once you're proficient with it, you're going to know the structural formula easily. So what is methanol? Methanol is one carbon with an OH group, and there is H, H, and H. Okay? This is methanol. Now, in order to deduce its structural formula, what are you going to do? You're going to first look at this part. Okay? You just write it as CH3. Okay, this is carbon and 3 hydrogens. Do you agree with me? So for structural formula, I'm going to write CH3, and then you have an OH, then an OH. Okay, so this is going to be a structural formula, CH3OH. CH3OH. Okay, what I did was I just broke it down into this part, CH3, and then I wrote OH. So that tells about my structure. Okay, so you don't have to draw this, you just have to write this formula. Okay, let's move on to the next question. So we have pretty much questions left. Okay, complete table 4.1 to show the effect, if any, for each change of conditions. Okay, change of condition is temperature is decreased. Effect on the concentration of carboxylic acid X. Okay, now what we're doing is we're decreasing the temperature. Okay, let's look at our equilibrium. Always remember this point, that whenever temperature is decreased, equilibrium will move towards the exothermic side. Okay? Equilibrium moves towards the exo side. And whenever temperature is increased, equilibrium will move towards the endo side. Okay? So now we are decreasing temperature. So equilibrium will move towards the exo side. And when equilibrium will move backwards on the exo side, because exo side is backward, the concentration of acid X will decrease, because we're forming most of the ester in water. We're moving this way. So concentration of X, we're going to write that it decreases. Okay, concentration of this is decreased. Now remember one thing, whatever we do, okay, now they're saying that concentration of this ester is decreased. Okay, equilibrium will always try to balance out any changes we make in it. Okay, so if we decrease this part, equilibrium will shift towards this side to increase it. Okay, let me repeat my statement. If I decrease ester, equilibrium will move towards this side to increase the ester, to produce more of it. Whenever I do any change to the equilibrium tries to reverse it. For example, if I remove this, equilibrium will shift towards this side to produce more of this thing, because I removed it. Equilibrium wants it back. So when I remove this, I decrease its concentration, equilibrium will move towards this side to produce more of it. And hence concentration of X will again decrease, because equilibrium will move towards this side. So we're going to write that decreases, because we are talking about concentration of X. More alcohol Y is added. Look, when you add more alcohol, okay, again, now you have added more of this. When you add more of this, equilibrium wants less of this. Okay, whatever you do, equilibrium tries to reverse it. So equilibrium will move towards this side, form more reactants so that this is reduced. So again, it will move toward this side, X will decrease. Because more of this Y we have to reduce it. So equilibrium move towards backward side. So it's going to be decreases. Equilibrium just tries to reverse whatever you do. Okay? A catalyst is added. A catalyst does not have any effect on the position of the equilibrium. So it's going to be no effect. Okay? Always remember, catalyst doesn't affect your equilibrium position. Okay? At the beginning of the reaction between ester and water, no carboxylic acid X is present in the reaction mixture. Suggest how the pH of the reaction mixture changes from start of the reaction until equilibrium is reached, as alcohols and esters are neutral. pH in start and pH at equilibrium. Okay. At the beginning, okay, they have told us that between ester and water, no carboxylic acid is present. Okay, acids have a low pH. Okay, we know acids have a low pH, a pH lower than 7. Okay, no acid is present. So at the start of the reaction, they have told us that no acid is present, and we are assuming that our alcohols and esters are neutral, and water is already neutral. So at the start, we only have our ester and water, and we are assuming that esters are neutral. So we know that at start, the pH is obviously going to be 7. 7 is the neutral pH. But suggest how the pH of the reaction is at the start and until the equilibrium is reached. But at the equilibrium, we have our acid as well, because we just figured it out that this is the equilibrium forward and backward, and this is the acid. So we have acid as well. So the pH is going to decrease. pH at the end, so it can be 4 or 5 because it is decreased. Because now we have added, and now acid is also being formed. Acid formed. Okay? Identify the ion that causes change in pH. Obviously, the ion that causes a change in pH is going to be hydrogen ion. Okay, name the indicator which can be used to follow the change in pH. Always remember that we use universal indicator to follow the change in pH. I tell you why. देखें, whenever you're using any other indicator, for instance, I use methyl orange. No, methyl orange still has two colors. Let me take an indicator. Okay, this is my container, and in it I am using thymophthalene, okay? I am using thymophthalene, okay? Now thymophthalene is basically, in acid it's colorless, okay? It's going to be colorless, and in alkali it's going to be blue. So thymophthalene only tells me the color in acid and alkali, okay? Only two. Even if I have a strong acid, okay, I have an acid of pH 1 and I have an acid of pH 5. This one is a strong acid, this one is a weak acid. For both, thymophthalene is going to tell me that my color is going to be colorless because it's an acid. Thymophthalene never tells me either it's a weak or a strong acid. It only tells me it's acid or alkali. In alkali, it's going to be blue. No matter I have a strong or weak alkali. But universal indicator changes its color with the intensity of the acid. Okay? If I have a strong acid, pH 1, universal indicator is going to be red, and at pH 5, universal indicator is going to be orange. So I know that this one is more acidic, this one is less acidic. But for thymophthalene, at both pH 1 and pH 5, it's going to be colorless. So I don't know the intensity of the acid, but over here I know the intensity. I can follow the pH. If it's orange in color, I know it's going to be less pH. If it's red, I know it's more. So universal indicator help me follow the pH. Okay? Sulfur is a group 6 element. Okay? That's a 6. A sample of sulfur contains two isotopes S32 and S34. Complete table 5.1 to show the number of protons and neutrons in one atom of the isotope of sulfur. Okay? We have to calculate the number of protons and neutrons. And that is at the top. What we're given with is always the mass number. So we don't know the number of protons. We got to consult the periodic table for that. Okay, in the periodic table for sulfur, we can see that it's 16. So it is going to be 16 for sulfur. Both of them, they're going to have 16 protons because proton number remains the same. And now 16 minus 32, 32 minus 16 is going to give you 16 neutrons over here, and 34 minus 16 is going to give you 19 and 18 protons over here. Neutrons over here. Oh, sorry, I'm so sorry for this. Neutron number is changing, proton number is not, because in isotopes, your neutron number remains the same, your proton number differs. Okay? State why these isotopes have identical chemical properties. Remember that isotopes always have identical chemical properties because they have the same number of electrons, and electrons determine the chemical properties. So we're going to write same number of electrons, hence same electronic configuration. Okay, state the mass of this many atoms of S34, include units in your answer. Okay, the mass is always in atomic mass unit, so it's going to be AMU. Now, let me explain to you what's going. these many atoms, ठीक है, what is this? This is Avogadro's constant. You guys remember from mole concept that this number is known as Avogadro's constant. And what is Avogadro's constant? Avogadro's constant is the number of, it's basically the number of atoms in 1 mole of any substance. So basically they're asking the mass of 1 mole. Cut it down, and instead of it, because this is going to confuse you, so what we do is, do we have any kind of tape or something? Yeah, just put a tape over here. This is a tape. Put it over tape over here. Don't see this thing, okay? And instead of it, write 1 mole, because now it's more easy for you to identify what is it. This means 1 mole, okay? Now read it. It's going to be much easier for you. State the mass of 1 mole of S34 atoms. Include units in your answer, okay? 1 mole means basically your mass number. 1 mole means your mass number, okay? So what do you guys think? What is going to be the mass of 1 mole of S34 atoms? 1 mole of S34, whatever. Okay? That is going to be 34. How do I know it? Because look, 1 mole of S34. What is 34? Look at 34. 34 is indeed your mass number. And 1 mole of anything has the mass equal to its mass number. 1 mole of carbon has mass of 12 because 12 is its mass number. 1 mole of oxygen will have a mass of 16. Why? Because 16 is the mass number of oxygen. So it's going to have 34 atomic mass units. So I'm going to write AMU with it. That's atomic mass unit. That's the unit because they asked for the unit. That's going to be 34. This top number is indeed your mass number. You had the answer in the question. You just had to think about it. And first of all, that's very important to know that now we erase the tape and we see that it's very important to know that 6.02 into 10 exponent 23 is basically your 1 mole. This means 1 mole. Okay, so we're done with it. Let's move on. State the name of the amount of substance which contained this. That was 1 mole substance. That was what we had to figure out over here. Table 5.2 shows the relative abundances of these isotopes of sulfur. Complete the relative atomic mass of sulfur in this sample to 1 decimal place. Okay, you have to learn this. I'm just going to do it, and that's a simple formula I'm using. 95 over 100 into 32. That is for first you take its percentage, write it on the top, over 100 into its mass number, which is at the top, which is 32. For the second one as well, I'm going to follow the same plus the second one. Second one is 5% over 100 into its, this mass number is 34. Put it onto your calculators. Okay, it's 95 over 100 into 32, and put brackets around it. Just add it into plus 5 over 100 into 34. And that's going to give you 32.1. Done with our answer, 32.1. Let's move on. Okay, sulfur reacts with magnesium to form magnesium sulfide, an ionic compound. Complete the dot and cross diagram in figure 5.1 for the ions of magnesium and sulfur. Give the charges. Ion of sulfur is in group 6, so 2 negative. Ion of magnesium is in group 2, so 2 plus. Okay, that's simple basic chemistry. You just look at the group number and identify the charges. Okay, now we have to complete the diagram. So we have to figure out how many electrons sulfur has. Okay, and then from that we have to subtract, to add. Magnesium is 12 and it was a charge of 12 electrons. This means this is the proton number and the electron number is the same. Okay, now we had a charge of plus 2. 2 means 2 more protons, so it is going to lose, out of these 12 electrons, it is going to lose 2, minus 2 is going to give me my electron number. It is going to have 10 electrons because a charge of plus 2 means lost 2 electrons. For magnesium, I'm going to draw 10, and for sulfur, where is sulfur? Sulfur is 16. 16, I'm going to add 2 electrons because it had a charge of 2 negatives, so it's going to be 18. Okay, so for sulfur, it is 18. Just let me write it over here. For sulfur, I have to draw 18. And for magnesium, I have to draw 10. Why 10? Because indeed magnesium had 12, but 2 plus means it is lost 2. So I already have 2. I just have to do 2, 3, 4, 5, 6, 7, 8, 9, and 10. For sulfur, I already have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I just have to draw 8 more. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, done. State why MgS has a high melting point. It has, you should know, it's an ionic compound. Mg is 2 plus, sulfur is 2 minus, strong electrostatic forces of attraction holding the oppositely charged ions. This is positive ion, this is negative ion, attracted towards each other by strong forces. So it has strong electrostatic forces of attraction holding the oppositely charged ions. Okay, state why molten MgS conducts electricity. Because it has free mobile ions. Because when it's solid, the ions are fixed, but when it's molten or it's dissolved in aqueous solution, the ions are able to move. Okay, an acid containing sulfur reacts with sodium hydroxide. Okay, that's going to be sulfuric acid. It can be NaOH to form salt in water. Salt has the formula this. Reduce the formula of the acid. H2SO4, sulfuric acid. Simple. Reduce the formula of the anion in SO. Okay, there's a problem here that you got to figure out one thing. Okay, what is the problem? You have to only write the formula of the anion. Okay, if you check, there is one thing. Okay, it might not be. Okay, H2SO3. This is also an acid and it is known as sulfurous acid. Okay, now I'm gonna tell you one thing. So what we're gonna do is plus, they told us NaOH, and now we form water, H2O. For H2O we get our H2 from here, okay, and our O from here, okay. H2 from here, O from here, H2O formed. Now Na from here and SO3 from here, so it's gonna be H2SO3, okay. H2SO3. If you figured out this mistake, you guys are really going good with your chemistry. If you figured out, if you didn't, then you got to work hard. Deduce the formula of the anion in this. It's gonna be, you know that sodium is always a +1. Okay, I know my sodium is always gonna be a +1. 2 sodiums I'm using, so total charge of +2 I have. To balance it out, this ion must have a charge of -2. So it's going to be deduce the formula of the anion, SO3 to negative. Okay, Na2SO3 is oxidized by acidified aqueous potassium manganate. State what VII refers to the name in potassium manganate. It refers to, VII means 8, oxidation state on Mn, manganese. Okay, oxidation state of Mn, which is +8. Mn, this is what it means. Okay, state the color change when this reaction happens. Oxidized by, okay, this potassium manganate is purple in color, so it's going to be purple. And when it oxidizes something, because it's a strong oxidizing agent, so it's gonna turn it into purple to colorless. Okay, let's move on. Glucose is involved in two processes. Okay, is made in plants from carbon dioxide and water. Name this process. Do you guys remember we used to make glucose in plants from CO2 plus H2O? Plants used to get it. They used to photosynthesize in the presence of sunlight and chlorophyll. So that's going to be photosynthesis. Okay, write the simple equation for this process. Just you should know, you take your carbon dioxide, you take your water, you take 6 of this, you form C6H12O6, and you form oxygen gas, which is 6 also. State two essential conditions needed for this process to happen. Photosynthesis can't take place without sunlight, and if you don't have chlorophyll, you cannot do photosynthesis. Glucose is converted to ethanol. Name this process. Glucose converted to ethanol. Fermentation. Third one is, देखिए, remember we used to take C6H12O6, ferment it in the presence of yeast, 25 to 35 degrees Celsius temperature, anaerobic conditions, and then we used to form 2 CO2 gas plus 2 ethanol, C2H5 and OH. Okay? And that was fermentation. By the process of fermentation, we convert our glucose to ethanol. Okay? Name the other product formed when glucose is converted to ethanol. We just discussed it right now. Carbon dioxide. Ethanol is made by reacting ethene with steam. That is, this process is known as catalytic addition. I'm just writing it so fast because I've learned all this. You guys learn all this from the syllabus, you're gonna be good to go. State the conditions for this type of and the type of catalyst. Okay? You should know that what they're talking about is basically you're taking ethene, C2H5. This is your ethene, H4. Okay? This is your ethene. You basically add steam into it, H2O, in gaseous form. Okay? And you form C2H5OH. Okay? This is how you form ethanol for industrial use. Okay? You take your ethene, you add steam into it, and you form ethanol. The conditions that you use to do this is, first of all, the temperature you are going to use is 300 degrees Celsius, pressure is 60 atm, and the catalyst is an acid catalyst. And the name of that acid is not part, but still you should know that it is H3PO4, which is known as phosphoric acid. Okay? This is the acid you use. Okay? Explain why this reaction is addition. I'll explain you one thing. देखिए, always remember that in addition reactions you have two reactants and one product. Okay? In substitution reaction you have two reactants and two products, but remember, whenever they ask why this reaction is addition, you see that your reactants are two, product is one. Always, because this thing is added into this thing and you form a single product. So the answer for this reaction to be an addition reaction is going to be a single product is formed. Okay, let's move on. Okay, complete the dot and cross diagram for a molecule of ethanol. Okay, now what's basically happening is, you should know carbon has 4 electrons. Carbon has 4 electrons in its valence shell. Carbon always makes 4 covalent bonds. Okay, so this is one carbon. Okay, I see this is one carbon. So 3 covalent bonds, 3 hydrogens. It's going to make it with 3 hydrogens. And it has one more carbon in it. So this is first bond of carbon, second bond of carbon, third bond of carbon, and fourth bond of carbon. Okay, so let's draw all the bonds of carbon. It is going to be this, and this. This carbon also has, remember, this carbon also can make 4 bonds. It has already made one bond with this carbon. Now it will make one with hydrogen, one with this hydrogen, and one with oxygen. 4 bonds completed. This 1, 2, 3, and 4 bonds. Carbon, remember, always makes 4 bonds because it has a valency of 4. 4 bonds over here. Oxygen has a valency of, it's in group 6. It needs just 2 more to get to 8. So oxygen will always form 2 bonds. So one over here it's formed, one over here it will form. Done with all the bonds. here we go to the end of our paper. If you liked my video, subscribe to my channel, and that would mean a lot. Do subscribe and like my video. Thanks for watching. Bye bye.